I'm Jamie. My science experiment was done on trying to determine the effects of impurities in different types of water, and we were able to see those impurities based off of the clarity of ice cubes. I wanted to see which types of water had the most impurities or contaminants in them, so I was able to use spring water, purified water, or tap water. My hypothesis was that purified water had less impurities than tap water or spring water, so it would produce a clearer ice cube. The purified water goes through an extra filtration process than spring water or tap water. This is why I made that hypothesis. My outcome was that purified water would produce the clearest ice cubes, and that the purified water goes through a filtration process even though it comes from all different sources of water. Where spring water comes more from our springs or from rainwater, tap water, of course, comes from what our cities produce through their own filtration systems. This experiment will determine whether or not my hypothesis is correct and whether purified water will produce the clearest ice cubes. Spring water is kind of in there only because I feel like that is a more natural, it goes through a natural filtration process. I did research some of what the difference is between the purified water and the spring water. Again, purified water goes through more of a filtration process. Our spring water, such as Zephyrhills, does go through a filtration process, just not to the same extent that the purified water is. I made sure that the water I used was Zephyrhills spring water. I used Aquafina purified water, and I did use my tap water from home, which does go through my city's filtration process. So it's not well water, it does go through a filtration process with my city. I was able to locate something on my city's website to tell me what their reports were from their tap water. There was some contaminants in it, and I was able to determine what type of contaminants. However, I don't need to know the types, I just need to know which water is more pure so that it produces the clearest ice cubes. So some of the vocabulary we need to make sure that we're aware of is that the room temperature for the normal room temperature is 68 to 77 degrees. When I completed this experiment, my room temperature was set at 74 degrees. I made sure that all water started at room temperature. I did not want to put the water through any other filtration processes such as boiling or anything like that. I did not want to use cold water because I didn't want anything to settle. I wanted it to be exactly room temperature so that each type of water was starting from the same starting point. The water will have to be frozen since I am going to be checking the clarity of ice cubes, so I needed to make sure that my freezer was set below 32 degrees Fahrenheit, which it is, so I was able to freeze that. Impurities are just what different types of contaminants that are in the water. Clarity is just how transparent is the ice cubes, how clear is the ice cubes. So that is what I will be checking after that water has froze. Purified water is just where it's gone through a filtration process so that contaminants have been removed. And spring water is just water that comes from rivers or rainwater or springs. Purified water does come from all different sources, but again goes through that filtration process. The science concept that I am applying to this experiment was just to see how much of the contaminants are removed from purified water so that it produced a clearer ice cube. The water with little contaminants will produce mostly clear. There should not be any cloudy. There could be a little bit of cloudiness, but it should mostly be clear. And then any of the contaminants that are in the water will actually produce the cloudy look that we sometimes see in ice cubes. And what happens is that pure water will be the first to freeze, and all those contaminants that are in the ice cubes, or in the water rather, will all be condensed and pushed into the middle of that ice cube, and that will be the last part to freeze of the ice. So that cloudiness that you see in ice cubes is the contaminants that are found in the water. So as you can see, my Manipulated variable are the types of water that I used: spring water, tap water, and purified water. My responding variable would be the clarity of the ice. So when I freeze this, the clarity of the ice is what I'm looking for, so that's my responding variable. My constants is the amount of water that was placed into each of the slots on the ice tray. The ice trays were all the same, and everything was put into the freezer at the same time, and all of the water was at room temperature prior to being put into the ice trays. The materials I used, I did use just regular ice trays, but I made sure that I grabbed all of the same brand. These all came in the same package, so I was able to get a package of 3. I only filled in 10 slots because 10 trials was all I was going to do. And to ensure that each of these slots in the ice tray were at the same amount, I made sure that I filled them up to the very top of that slot without it spilling over. That is how I was able to ensure that I used the same amount of water in each slot. I made sure to put all of my ice trays on a baking sheet so that whenever I got ready to transport them and put them into the freezer, it was all done at the same time. So there was not one tray that was put in before the other. I also made sure that I used placeholders that I created from index cards. This had if it was spring water, tap water, or purified water. This is so that none of my trays were mixed up and I did not get mixed results, because I knew where the water came from, where it started, and I kept these placeholders under the ice trays so that when I pulled that the baking sheet out of the freezer, I still knew which tray contained which type of water. I just used the regular 16.9 ounces of water. So I used Zephyrhills spring water, I used Aquafina purified water, and whenever I used my tap water to ensure that, again, that I had the same amount, I emptied, cleaned out, and dried a Zephyrhills water bottle and filled that with tap water, which I left on the counter, and so that all of the waters were at room temperature prior to filling the ice trays. And I did create a rubric so that I was able to use that for my data whenever I was ready to pull the ice cubes out of the tray. So my procedures were to gather my materials, and as you can see, I have taken a picture each time that I was pouring the water. So I started with the spring water, went to the tap water, then to the purified water. And again, I made sure that each of those slots in the ice tray were filled to the top of the slot so that I was able to ensure that each slot had the same amount of water in there. Again, I only filled 10 slots because I only was going to complete 10 trials using this water. And I made sure that my ice trays stayed on the cookie sheet. So again, I was able to transport those ice trays to the freezer at one time, place everything in the freezer so they were on the same shelf. There was nothing, none of the ice trays were ever getting different treatment, so that way I could make sure that all of my results stayed equal with each other. Once I was done and I was able to pull those the ice trays out of the freezer, which I did leave them in for 24 hours to ensure that the water was frozen, I have my rubric here that I used for my point scale. So my point of 4 was to show that there was no cloudiness in the ice cubes at all. This shows that there was no impurities in this water when it was frozen. A point scale of 3, there is, as you can see, a little bit of cloudiness in the middle, but there's mostly clearness around the outside of the ice cube. Point 2, mostly cloudy with a little bit of clarity around the edges, and number 1 was all cloudiness in the ice cube. This shows that this water is full of contaminants, and that's usually what I see when I pull the ice out of my refrigerator from my automatic ice maker. As you can see, the average for tap water for the point scale based on clarity was 2.3, spring water was 2.7, and purified water was 3.5. At this point, I was able to see that my hypothesis was correct, that purified water did create the clearest ice cubes. Just more data that I had here, where my median for tap water was 2, my spring water was 3, and my median for purified water was 3.5. Again, that is based off of a point scale from 1 to 4. This is the graph that shows that I used my average when I was checking for the clarity and putting in the graph. So for my spring water was 2.7, my tap water 2.3, and my purified water was 3.5. So again, my graph shows that my purified water had the greatest amount of clarity in the ice cubes, and so that was my more pure water. This is the results. This is where I was recording that out of my purified water, I actually had 5 ice cubes that I was able to score 4, meaning that they were completely clear. And I had 5 ice cubes that were scored at a 3, which meant there was just a little bit of cloudiness in the middle, but not a lot. And I did make sure that I pulled every single ice cube out of the slots and checked every one and recorded my data. The spring water had several cubes that resulted in a 3, meaning that they had a little bit of cloudiness with some clarity around the edges of that ice cube. And tap water was at a 2.3. There was more cloudy in the tap water than in the spring or purified. This is just the conclusion, which shows the purified water was able to produce the clearest ice cubes. So my hypothesis was correct that the purified water contained less contaminants, so they produced clear ice cubes and more transparent ice cubes. Spring water came in next, and tap water had the most contaminants because it produced the cloudiest ice cubes, number of ice cubes, I should say. If I wanted to use this in the real world, I would use this application because we are constantly looking for the cleanest drinking water. This is one way to determine what type of water is the cleanest as far as the removal of contaminants and purity. So if I wanted to see that whatever purified water, whatever that filtration system that purified water is using, does produce the cleanest drinking water. My narrative shows that on April 14th, I was able to clear this experiment with my instructor and get his approval on it. And then between April 15th and 17th is when I started to prepare everything, gather my materials, and set up my experiment so that I was able to get it ready and get it in the freezer. April 18th is when I pulled everything out so that I could check my data and record the results. And on April 20th, I finished my PowerPoint so that I could present this to you. This is just a more clear picture of the color of the ice cubes, and as you can see a difference that purified water did produce more clear ice cubes than spring or tap water. Thank you.